Dear students, Assalamu alaikum and welcome to the 17th program on Software Engineering 1 course. We discussed in the last few programs about the techniques and methodologies that are very useful in user requirement gathering and designing a complete system that satisfies all the user requirements. Once the design is complete, coding can begin where physical design specifications are turned into working code by the programming team in a suitable software development environment. Depending on the size and complexity of the software, programming can be an involved and intensive activity. Once the coding is begun, the testing process can begin and proceeds in parallel with the development. Testing is a very important activity of a software development process. And it is precisely this activity that we are going to discuss today. In today's program, we will discuss what is software testing process, and some testing techniques that are geared to discover program faults and errors. But before we define and discuss software testing itself, it is important to understand the difference between an error and a defect in software engineering. In software engineering, an error is defined as a flaw in software engineering work product or deliverable that is uncovered by software engineers before the system is delivered to the end users. A defect is a flaw that is discovered after delivery to the end user. Dear students, there are a few things that should be noted here. First, by error, we do not only mean that our code has some errors and fails to deliver some functionality as required by the users. But if the system does not satisfy the non-functional requirements, such as reliability, efficiency, it should also be treated as an error. The types of error which can result in failure of a software include omission of requirements. That means some of the requirements have not been implemented by the programmer or in the design. Incorrect specification, which might have been obtained during the analysis or the design phase, and they have been wrongly implemented. Then there might be errors in the high-level design. For example, our architectural design might not be the accurate design. The errors in the low-level design, such as the logical errors. Then your code may also have some errors. The errors might be syntax or semantic errors, which needs to be removed. Then user interface errors might also be there. That means you might be getting the wrong output or incorrect error messages. Then your system might not perform according to the specification. It might not exhibit the reliability and efficiency that is required by the user. Then there might be errors in the documentation you have prepared. Now you should remember here that by software we mean the program as well as the documentation which is prepared for that software. Then there might be errors in the module interface, and your program or software might not be properly handling the exceptions. Of course, there might be many other types of errors which you can come across while you are designing and implementing and testing the system. It should be a priority of a software developer to make sure that when the software is delivered to the user, it is error-free, which is a really very hard thing to achieve. Nevertheless, software engineers can try to minimize the number of errors in a delivered product. Software testing activity achieves just that. Formally, software testing can be defined as: software testing is the process of exercising a program with the specific intent of finding errors in the software. So software testing is not about testing the code only as is generally believed. Rather, it is a much larger activity, as we'll see shortly. A comprehensive software testing should show us the errors in our programs, code, documentation. It should exhibit whether the software and related documentation conforms to the user requirement. It should exhibit whether our software performs according to the required reliability and efficiency criteria set by the user, and whether the software has adequate quality which is required by the user. We should remember that the purpose of software testing is to uncover errors, and therefore testing cannot show the absence of errors. It's very important to note that testing can only show that software errors are present. Therefore, a good software testing technique is that technique that has a high probability of finding as yet undiscovered error. Dear students, virtually all developers know the frustration of having software bugs reported by users. When this happens, developer inevitably asks a question: how did those bugs escape testing? Countless hours went into the careful testing of hundreds of thousands of variable and code statements. So how could a bug have eluded such vigilance? The answer requires, first, a closer look at software testing within the context of development and what testing techniques were used for a particular software. Second, it requires an understanding of the role of software developer and tester. So let's first look at who is responsible for testing the software and related documentation. Now, basically, there are two major parties which are responsible for testing the software: the developers themselves and independent testers. Now, of course, developer understands the system, but the problem with the testing done by the developer is that generally they do the testing very gently, and that testing too is driven by the delivery deadlines. Whereas an independent tester must first learn about the system and the functionalities required by it. But of course, he will attempt to break it, and he is driven by quality. So in a real environment, the testing has to be done both by the developers and by an independent team. Now, there are two approaches to software testing. In the first approach, we formally prove that the system is failure-proof. This is possible if we have a formal definition of all the components of the software and requirements. Now, this approach is not used much, though considerable research has been made and still done in this area. The second approach relies on performing certain tests designed to find errors in software, and no formal mathematical proof is provided. There are different techniques that can help develop appropriate tests. We'll focus on the second approach, and we'll discuss what tests should be performed and how they should be performed to test a software. But whatever approach you use for testing, testing generally begins at the component level, at the smallest level. You might remember that we discussed this thing before, that a system is made up of various components which are integrated and they work as a unit. So testing also starts at the component level and then works outwards toward the integration of the entire computer-based system. In a conventional software testing strategy, we start with unit testing and concentrate on each unit or module of the software as implemented in source code. Then we move to integration testing, where tested components are assembled or integrated to form a complete software, and the system as a whole is tested. Integration testing basically addresses the issue of verification and program construction. That is, making sure that the system has been developed according to the design and the components work together cleanly. After the software has been integrated, a set of high-level tests are conducted to make sure that the software does what the user really wanted it to do. That is, software satisfy the real user requirements. Validation testing provides a final assurance that a software meets all functional, behavioral, and performance requirements of the users. At this point, it is important to note that any testing strategy will fail if certain issues are not properly addressed. For example, for effectively employing a test strategy, one must state testing objective explicitly, understand the user of the software, and develop a profile for each user category, conduct formal technical reviews to assess the test strategy and test cases themselves. And above all, testing and test should be planned long before testing begins. Test planning can begin as soon as requirement modeling is complete. And test cases can be designed as soon as the design model has been solidified. So we have the wrong notion that testing basically is concerned only once the code has been developed, which is not true. Basically, we should do the testing and start doing the planning for the testing, that how different components will be tested while we are doing the analysis and the design of the software. Dear students, there are two complementary types of testings. So in static testing, we concerned with analysis of the static system representation. That means the programs and the documentation to discover errors there. Whereas in dynamic testing, we concern ourselves with exercising and observing the behavior of the product. Both types of testing is important and has to be carried out. Static testing involves analysis of source text or the code by humans or by software. It can be carried out on any document produced as a part of software process. The objective is to discover errors early in this software process. It is usually more cost-effective than testing for defects detection at the unit and module level. It also allows error detection to be combined with other quality checks. Static testing involves analysis of source code by humans or by a testing software. It can be carried out on any documents produced as a part of the software process. The objective of static testing is to discover error early in the software process. It is usually more cost-effective than testing for defect detection at the unit and module level. It also allows error detection to be combined with other quality checks. Static testing is not only useful to test non-code elements of the software, such as documentation, but it has been shown to be very effective to discover certain type of errors in the code. Statistics show that more than 60% of program errors can be detected by informal program inspection. And more than 90% of program errors may be detectable using more formal program verification techniques such as program inspections and structured walkthroughs. During static testing, we can discover certain types of error, such as data fault. The examples are, for example, the variable used before they are initialized in the program, variables declared in the program but they are never used, variable assigned twice but never used between assignments, which is a useless activity. You can also check for possible array bound violation by the programs, and you can also check the undeclared variables. With the help of static testing, we can check for the control fault, such as unreachable code. We can also check for input-output faults. For example, variable output twice with no intervening assignments. That value of the variable was printed twice, and the value of that variable did not change in the program execution. We can also test for interface faults between the modules. For example, we can check for parameter type mismatches from the calling program to the called program. We can also check for the parameter number mismatch. For example, if a function requires 3 parameters, you can check that you are passing the right number of parameters and the right type of parameters. You can also check for non-usage of the result of functions, that you make a call to a function, but the result returned by that function is not used. And you can also check for uncalled function and procedures which have been developed but not used. Another category of static testing check includes the storage management faults. For example, you can check for unassigned pointers and very common errors which happen in the pointer arithmetic. So you can see there is a long list of errors which can be checked with the static testing. But on the other hand, the objective of dynamic testing is to discover errors in running systems. That means we execute the program, provide some input to it, and then we see how the program behaves. In dynamic testing settings, we run the system or a component, provide it with some input, and observe the output to make sure that the system takes the correct input and provides the correct output. Also, dynamic testing is vital to test the conformance of the system to efficiency and reliability requirements, which generally not possible with static testing. The dynamic testing of a system can be done at various stages and level where you are developing the system. For example, we can do the unit testing, where each module which we develop is tested in isolation independently from the other modules to make sure that each module developed by us works as per requirement. Then we can perform the integration testing, in which a number of modules are integrated and they are tested to make sure that once these modules are integrated, they will work correctly according to the specification. We can also perform function testing to make sure that the system as a whole provides the functionalities required by the user. We can also perform the performance testing, making sure that the system provides the performance requirement to the user. We can also do the acceptance testing, in which the client is invited to test the software for acceptance. And generally, acceptance testing is done once the whole system has been developed. And acceptance testing is also called the alpha testing. Then, Installation testing can also be carried out, in which we install the system on site and the software is testing again to make sure the software is going to work properly in the real working environment. Another kind of testing which is used is called the beta testing. In beta testing, the software is given to many customers for them to install and test with no test guidance at all. So you can see the testing can be done at different levels and might be done by different people. We have emphasized the point many a times that each software development process activity should be performed according to a suitable and well-defined process. This is also true for software testing activity. Testing should not be treated as a single and isolated activity. Rather, it consists of a number of smaller activities which need to be performed. A dynamic testing process generally consists of these steps. First, we design the test cases, and the result of this activity is test cases. Now, test case basically includes the input you will give to the system and the expected output that will be produced by the system. Then we prepare test data. Test data is basically only the inputs which will be given to the software to test it. So we get the test data. Once we have the test data, then we run the program with our test data, and of course we check the test, we get the test results. So the results which are obtained from the program, they are compared with the test cases, and then we prepare a test report which indicates whether our system has some errors or not. So test data is basically input of the system that is devised to test the system. Test data can sometimes be generated automatically. We have available many automatic testing software, whereas the test cases include inputs to test the system as well as the predicted output from these inputs. If the system operates according to the specification, test cases cannot be generated automatically since it is impossible to predict output. Dear students, there are two complementary approaches that are used for dynamic testing. They are generally known as Whitebox testing and Blackbox testing. We'll touch upon both of these techniques very briefly. In the Whitebox testing, we basically test the code. So our goal is to make sure that all the statements and conditions have been executed at least once. So in Whitebox testing, tests are conducted to ensure that all internal operations are performed according to the specification, and all internal components have been adequately exercised. In Whitebox testing, you see, again, we can start with the component. We have the code of the component. From the code, we can derive test data. Then that test data can again be input to our program, and we can take the test output, and then we can compare our test output with the predicted output to make sure that the component works according to the specification. So in Whitebox testing, we use the program code and requirement specification. A software engineer can drive test cases that guarantee that all independent parts within a module have been exercised at least once. These test cases can be used to test the component itself. We'll discuss different techniques which are used for Whitebox testing in our next program. But on the other hand, In black box testing, we verify whether or not a system or a component provides all functional requirements. So black box test examines some fundamental aspects of a system with little regard to the internal logic structure of the software. That means in black box testing, we have the system which is treated as a black box, so the tester doesn't have to know what is the logic, what is the coding inside the system, and how the system works internally. We take some input test data, which can generally produce some errors in the software. Then we give that input to our system, and we get the output. Now, output can reveal the presence of defect. So, in the black box testing, the important thing is that the user can only see how the system takes the input and what outputs are produced. But how the system basically produces that output is invisible to the user. So we are not interested in the logic of the program. Now, black box tests are used to demonstrate that software functions are operational. That is, input is properly accepted by the software, output is correctly produced, and integrity of external information, such as data file, is maintained. The test cases are generally derived from system specification in the black box testing. Dear students, in today's program, we discussed what is software testing. Then we discussed the software testing process, and we briefly mentioned some testing techniques that are geared to discover program faults and errors. We'll continue our discussion on testing in the next program as well. But if you have some comments and suggestions about these programs, please do write us on the address given on your screen. So till the next program, Allah Hafiz.